We are going to do uniform motion problems where we have a total distance that is split into two different parts, one way or another. Up to now, you've done the ones where we have one distance equals another distance, either going in the same direction or going in opposite directions. Today, we're going to have to add two pieces together to get the whole distance. If you will go ahead and get this copied down, you still need to always do two rows in your diagrams. It may be you go in one kind of vehicle and then in another kind of vehicle before you get to your destination. Maybe you go by train most of the way and then Uber the last few blocks or something. Maybe it's like my son and me meeting in the middle. Maybe it's you start at the same place and go opposite directions. But the diagram always has to have two rows in it so that once you write it, you look at it and you say, oh, my top row and my bottom row are equal. The top row is D1 plus D2. The bottom row is the total distance. D1 plus D2 equals the total distance. And then you put in RT for each of the Ds. So our first example, Napoleon is going to the battle site. And he walks for a while, and then he's tired of walking, so he rides on a caisson. How many of you use caisson in your everyday vocabulary? I sure don't. It's some kind of a wagon, so just something that he could ride in. So he's starting, and he's trying to make it over here to the battle site. He walks part way, and then he gets in that caisson, and he rides the rest of the way. So I'm going to do W for walk and R for ride. I could have done C for caisson, whatever you like in there. I need a second row because my diagrams always have to have two rows. Can anybody tell me how long that bottom line needs to be? Where in the problem does it say how long? Thank you, Joyce. Everybody good with the 60 miles for the total? Look at my picture. The left edges are even, the right edges are even. The top row is just as long as the bottom row. The top row is dW plus dr. That is just as long as the bottom row, so that equals the bottom row, which is 60. Then change the D's to RT's, because rate times time equals distance, and put in the subscripts. Now you guys need to help me find other things in there. Are there any things in there that I can start to substitute into that equation? The faster you volunteer, the more work time you end up with. Read the rest of the problem. What else can we plug in? Lucia? 30. So 3 for rate walk. Thumbs up, thumbs down. Are we good with that? Okay, so we've done these two. Then the other piece of information that they give us is the total time was 8 hours. So that means that TW plus TR is 8. So I need to do some kind of a substitution. I'm going to be a little bit smart here. How long did he walk? The only thing that it's asking me to find is the time walking. So I want to make sure that one stays in my equation. So when I do my algebra, I end up with TW equals and I can be done. So I'll keep the TW right here. But then I will change TR to 8 minus TW. And that has to equal 60. So you guys go ahead, distribute the 9, finish that. Let me know what you get for the time walking. sure the 9 gets multiplied by both things in that parentheses. And then look up at me when you have your answer for the time walking. Answer should be smaller than 10. So everybody hold up fingers for how many hours? And most have 2 fingers up, 1 or 2 different. Let's see what I can catch up and get. If I put the TWs together, I have minus 6 TW. And if I subtract 72 on both sides, negative 12. Negative divided by negative is positive. 2 hours walking to have a complete label. Thumbs up, thumbs down for that example. Do you understand it? All right, next one. Okay, I think we're out in the Wild West somewhere. We've got Chester going from the Roundup to Dodge City. So this is not my diagram, but just to make sense out of it, there's a Roundup taking place somewhere here, and then there's Dodge City over here somewhere, and Chester starts off here, and he's heading towards Dodge City. But then Marshall Dillon leaves Dodge City and tries to meet Chester. So we have the Marshall going this way. Does that make sense to everybody? So I will draw my diagram going in opposite directions, but trying to meet in the middle. And this can be how far Chester goes, and this can be how far the Marshall goes. My second row needs to go exactly as long as from end to end of those 2 arrows, not just a short little mark in between them somewhere. How long is that total distance? Do we know? Okay, I didn't call on you. Remember to raise hands, please. Yes, it's 66. I was waiting for other people to have a chance to read the clues and figure it out. So now, if you look at that picture, top row is as long as the bottom row. Top row is as long as DC plus DN. Bottom row is 66. Then each distance is rate times time with the correct subscripts. Now, raise hands if you can tell me something else that this problem tells me. Looks like it's going to ask me to find how fast each one rode. It's not going to tell me the rates. I'm going to need to find RC and RM. Does it tell me either time directly, Liam? Okay, let me get that marked. Everybody good with Chester goes from 1 to 9 p.m. And the times in these are not clock times. It's how many hours were they traveling. So that tells us that Chester's time was 8. Are we good with that? Ainsley, can you figure out for me Marshall's time? Well, what time does Marshall start? And what time do they meet? So how many hours is that? So very good. So the Marshall's time is going to be 7. Does it tell me anything about the rates, Harper? So how do I write that as an equation? And is 2 plus what twice means? 2 times the rate of Chester. Everybody okay with that? So I've got to find both of these. So I'm just going to plug that in for Rm, that it's a 2RC. And then I'll keep the RC here with the 8. And so let's see, I have 8RC plus how many? Family? So 14, how many RCs altogether? And so if 22RC is 66, everybody shout out for me. What's RC? 3, and I think it was miles per hour. Miles and clock time hours. So miles per hour for Chester to get our complete rate in there. So far, so good? Okay. Henry, how do I get Marshall's rate now? What up here says RM equals something. We've written the, which would be perfect. So Marshall's rate is 2 times that 3, so 6 miles per hour for Marshall Dillon. Thumbs up, thumbs down for how much sense that one makes now. Anybody with questions? All right, my last one. I did not make up the names. This is Saxon, Rocket Man, and Moonfa. And so at noon, Rocket Man starts off, and key in there, Moonfa goes off in the opposite direction. So they start at the same place and go in opposite directions. So I'm going to have one arrow going left and one arrow going right. Does not matter which one is which. So I will let this be Rocket Man's distance, and this can be Moonfa's distance. I need my second line in there. Do I know how long that total is? Can you find a clue in the context for how long the total distance is? Alicia, you see anything in there that says anything about the total distance of how far apart they are? Is everybody good with 11,800? And I drew that second line just as long as the top one. So the top line altogether is just as long as the bottom one. The top line is dr plus dm. The bottom one is 11,800. Change everything to RT because rate times time is distance. And make sure the subscripts match. So far, so good. All right, so now let's see what we can figure out next on this. We want to know how fast each went. So we need both rates. What else do they tell us? Help me figure out something about rates or times, numbers I can put in, or a relationship between them somewhere. What do you see in this that's going to help us? Max, what do you see in here that might help? Okay, so Moonfa 200 less than Rocket Man. Help me put that in an equation, please. Moonfa's rate 200 less than Rocket Man's rate. What does that mean I can write down? Thumbs up, thumbs down. Does that say that Moonfa's speed was 200 less than Rocket Man's speed? Okay, so we can go with that. So we've got something we can put in right here for this Rm, that it is RR minus 200, and then we'll keep this RR. Anything that I know about the times. Back up where you can see the whole thing. That would help a little bit. So tell me anything about how long they were each going. Nick, does it tell me anything about how long they each traveled? So say that again. When did Rocket Man start? And when did Rocket Man stop? Everybody good with Rocket Man goes from noon to 5? So how many hours, everyone? 5 for Rocket Man's time. What about Moonfa's time, Adam? Everybody good with 4 for Moonfa? Okay, so now we have 4RR plus distribute our 5. 5RR minus 1,000 equals, minus 1,000 equals 11,800. So what, 9RR, add 1,000 to both sides is 12,800. And anybody good at dividing that by 9 for me? Anybody else, just as a double check, getting 1,400? Help me out here. Somebody else either divide it by hand or calculator. Let's make sure we get this right. Is it 1,400? Okay, seeing some other thumbs up. So 1,400, and my units are kilometers per hour. And so this was kilometers per hour for Rocket Man. Okay, I also needed to get Moonfa's rate. Riley, how do I get Moonfa's rate? Oh, 1,400 minus 200 is 1,200 kilometers per hour for Moonfa. Thumbs up, thumbs down on what we're doing today. All right, whiteboards.